Meta has recently launched its most powerful LLM, Llama 3.1. We will see how we can create RAG with this 3.1 locally, and I'm going to tell you what are the steps that we are going to follow in this video to create our RAG. First, we will load our knowledge base, and knowledge base is nothing but you load your PDF file, CSV file, text, JSON, or any other file format. Second, we will load our embedding model. You can use any one, but I'm going to use Hugging Face embedding model because it is free. The step third is to create indexed and then store embedding to the disk. Fourth one is we will load those embeddings from disk to query our data. The fifth step is to create LLM with Llama 3.1 using Ollama. So instead of using any API key, we will be using Ollama here so that we can use this Llama 3.1 locally. And the last step will be query your data. We will ask questions to our data. Now let's go to our Jupyter notebook and execute these steps one by one and create our RAG. Let's first define our step 1. So I will write here step 1, and this is loading the knowledge base, any file, PDF, text, etc. I'm going to import simple directory reader to load my text file from LlamaIndex dot core import simple directory reader, and then I'm going to make an object documents. I will call this simple directory reader. Inside this, my first parameter is going to be input files, and my file name is paul_sa.txt. Then I'll close this, and then I will call the function load_data, which will load my data as documents, and then I can simply print documents. Let us execute our code. So this will print documents for me. Now here in the output, you can see that we have loaded our document here, and this is an essay from the author Paul Graham. You can read about this essay if you want. I have already shared the text file in my GitHub notebook, in my GitHub repo. You can go to the GitHub repo and download this text file from there. Now we will come to the second step. So I will write here step 2, load embedding model. And as I said, we are going to use Hugging Face embedding. So let us import from LlamaIndex.embeddings.huggingface import Hugging Face embedding. And then I'm going to create an object of this Hugging Face embedding class. I will write here embed_model is equal to Hugging Face embedding, and then let us execute our code. So embedding is a meaningful representation of text in form of numbers, and the embedding model is responsible for creating embeddings for the document chunks and user queries. So the document that we have loaded, for this, the embedding will be created by this model. Next, we will create indexed and store embedding to disk. Embeddings are created by embedding models, and they are stored in a vector store that offers fast retrieval and similarity search by creating an index over our data. I will write here step 3, indexing and storing embedding to disk. And I will be using here Chroma vector database to store this embeddings, and once I have stored this embedding to Chroma vector database, I'm going to load those embeddings and then start querying our data. I will write here import ChromaDB, then from LlamaIndex dot core import vector store index to create our index. From LlamaIndex dot vector stores dot chroma import chroma vector store. This will help us to create connection between ChromaDB and LlamaIndex. And then from LlamaIndex.core import storage context. Storage context help us to store our embeddings to any location, and in this case our ChromaDB. Let's execute our code, and here I see some error because I have to remove this dot from here. And now let me execute it again. It looks fine now. So now the first step that we are going to do is we have to create ChromaDB client. So I will write here create client, and then I will make an object db which stands for database, and then I will call this ChromaDB, and then I will call persistent client. Now what does it mean? Persistent client mean when you want to store your embeddings to your disk, you have to call this class persistent client. And then inside this I will give the path, and my path is going to be the current directory. That is why I will just write here dot slash, and then I have to give the ChromaDB database name. I will write here Paul underscore ChromaDB, and then I will execute the code. And if I take you to this page here, so you will see I have only two folders here. If I refresh this page, so you will see that I have only these two folders. Now I'm going to create this new database here, Paul underscore ChromaDB, and inside this I will create a collections where I'm going to store the embeddings. So next step is we have to create a collection inside this database, and once I will execute the code, you will see that folder here. Let us create a collection. A collection is nothing but it is inside our database where we have our index. So I will write here chroma underscore collection, and then I will call this db. From this I will call get or create collection. Now we are creating collection, and I will give the collection name as Paul underscore collection, and then I will close this, and let us execute our code. So this should create a vector database Paul ChromaDB, and inside this I will have this Paul collection. If I go here and if I refresh this page again, I should see this. So here in the output you can see Paul underscore ChromaDB, and inside this we have this Chroma SQLite S3. I'll go back here to this folder, and I'll just I'll be here only. And then when I will store this embeddings, you will see here one more object. Let's do that. So we have created our database Paul underscore ChromaDB, and we have also created our collection Paul underscore collection. Inside Paul collection we will have our embeddings, and now we will save this embedding to this collection. So I will make one variable vector underscore store, and then I will call chroma vector store. Inside this I will pass chroma collection, my first parameter, and then I will pass chroma collection that I created here, this one. So now we have a vector store of this chroma collection, and then I will call storage underscore context. Then I will call this storage context. From defaults, then I have to pass my vector store here. So I will write here vector store, and our vector store is nothing but this chroma collection. So I will pass this vector store here. So this is the main thing, this storage context. It helps us to write our embeddings. And now let us execute our code. So we have this storage context, and now we have this final step where we will create index, and that index will be stored in this Paul_ChromaDB database. If I refresh it here, you will see nothing now, just this Chroma SQLite. Let's create our index. I will make one object index, and then I will call here vector store index. From this I will call from documents, and inside this I have to pass the parameter. The first parameter is I have to pass document, because I want to create an embeddings of this document that I have just loaded here. So I will pass this document. The second parameter is going to be storage context. Storage context is equal to storage context. This will tell us that you have to store the embeddings in this vector store, and our vector store is nothing but our chroma collection, which is inside this Paul_ChromaDB vector database. And then lastly we have to pass our embedding model, because to create embedding of this document we need one embedding model. So we will pass our embedding model that we created above. Embed_model is equal to embed model, and then I will just close this. So this embedding model is nothing but the one that we have created here, this Hugging Face embedding. Now let us execute our code, and this will create an index for us and store it. So if I go here, okay, let me first finish this execution. It is still running. You can see here star. Well, let's wait for a few seconds. It has finished creating indexes and stored it in this Paul_ChromaDB. If I go here, and now here you can see that we see one new object here. In this object we have our embeddings. Now the next step is we will load this embeddings from this ChromaDB where we have created and stored, and then we will query our data. So now let's go to the step 4. I will write here step 4, and the step 4 is about load embeddings from disk that we have just created. And then let's load it. To load it, I will make one new object db2, and then I will call this ChromaDB here, ChromaDB, and from this I will call persistent client, and then I will give the path. So my path is going to be nothing but this one, because I want to load it from here. Now whether you want to store or whether you want to read it from that location, you have to call the same function persistent client. So now I will just keep this. I have given the path. The second is chroma collection, and then I will pass the collection name. So I will pass this db2. From this get or create collection, and our collection is this Paul collection. So I will copy it from here, and then I will paste it here, and then we will create vector store after loading this collection, and then I will call here chroma vector store. Inside this chroma_collection is equal to chroma collection, and then I have to create index. I will write here index, and then I will call this vector store index. Inside this, now I will just pass this vector store. Earlier what we were doing, we were passing our document, then storage context, then embedding model. But here what we are doing, we are passing this vector store because we already have our embedding stored in this chroma collection, and this chroma collection is nothing but Paul collection. So I will just pass this one, and then I will pass one more parameter, embed underscore model, that is our embedding model. This is nothing but this embedding model here, and then I will close this and let us execute our code. So it says that object diagram has no length. I have made some mistake here. Let me check what is the issue. The reason is after calling this vector store, I have not called the function. I am sorry for that. From vector store. Now let us execute this code again. So now we have loaded embeddings from our disk. Now comes the last part, or the second last part, where we have to initialize our Llama 3.1 model with Ollama. I will write here step 5, initialize Ollama and create LLM with Llama 3.1. So first I will import from LlamaIndex.llms.ollama, import Ollama, and now I will create an LLM. LLM is equal to Ollama. Inside this I will pass our model name, and our model name is Llama 3.1, and then request timeout. This is a parameter. This I'm going to give as 420, and I'll tell you what is this request timeout. So this argument sets a timeout for request to the language model. If the model doesn't respond within 420 seconds, the request will be timed out. You will get an error that is timed out, and you may get this error a lot of time, because if you have this machine with configuration of 8 GB RAM, then it takes some time. It has given me this request timeout a lot of time, and then I have to try it again and again. So in your case also, if you see that you are getting request timeout, please don't worry. You have to try it 2, 3, 4 times, because this model is huge, and then also our system is not that powerful, because my system has only 8 GB RAM. So you have to wait, you have to be patient while using this Llama 3.1 locally if you don't have a very good machine. Now let us execute this code. So we have created this LLM object, and now comes our last step, which is step number 6, query data. And then I will create a query engine here. So I will write here query underscore engine, and then index dot as query engine. So this index is coming from here, the index that we have created, engine, and then I will pass LLM is equal to our LLM that we have created here. And here I can show you this LLM details also. So if I print this LLM, we have this model name, which is Llama 3.1, and these are the default parameters, where you see temperature is given as 0.75, and then we have this context window and so on. These are the default parameters. So let us execute this code, and this has created our query engine. And now let's ask question to our Llama 3.1, the most powerful model that we have today. I will write here response, and then query engine dot query. Inside this I will ask query, what did the author do growing up? And then let's try, and this will take some time. So you have to be patient and you have to wait. I'll execute the code. After trying for some time, I finally got the response, and it says that the author agree of working on writing and programming with a focus on short stories and so on. This took some time for me because of the system's configuration. If you have a high-end computer, then definitely you will get the response quickly. And this is all about Meta's Llama 3.1 model, how you can use it with Ollama to create your RAG locally. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.